All right, let's start. Welcome everyone. Good morning. I hope you have your coffee with you. This is going to be a pretty technical presentation. My name is Enrico Campidoglio, and this session is about Git hidden gems. Now, before we start, I'd like to ask a few questions. So, number one, who here is new to Git? Maybe you use it, but you haven't been using it for a long time. Just raise your hand. Okay, a couple of you. How many here are, let's say, have been using Git for a few years and they feel like they are proficient, but they haven't looked into the advanced stuff? Okay, that's like most of you. And how many here are Git gods, Git masters? Okay, a couple of you. So my goal here today is for there to be at least one new thing that you didn't know about Git. So when you leave this session, you should have learned at least one new thing. And if you already knew everything I'm telling you about, then look me up afterwards because we might have a hobby in common. Okay, so let's get started. What gems, you might wonder? Isn't Git like a regular version control system? Well, yes and no. You see, Git is a bit like a Swiss Army knife. It's a tool that you all recognize. I mean, it has an obvious purpose. But it's also more than that. It has a few tools hidden away that you might not even know what they are for, but they are there. So yeah, so Git is the Swiss Army knife of version control systems. And yes, I'm quoting myself. So my goal today is to show you the tools that are hidden inside this tool, everyday tool, in order to improve your daily workflow. But first, let's address the elephant in the room, shall we? What with this ASCII art? Well, Git is a tool that was designed to be used from the terminal, from the command line. And that's always going to be that way, even though there are very good graphical GUIs built on top of it. Some good, some bad, but they do the job. But if you really want to take advantage of Git's full potential, you need to be using it from the command line. So yes, welcome to the terminal. This entire presentation is going to be from the command line. And yes, that includes even the slides. And you wouldn't believe how long it took me to draw that. So let's keep it up a few more seconds, and there you go. So what's the game plan? We have a screen. We divide it into two parts. On the right, well, my left, your right, yes, or the other way around. One side, we're going to have the terminal. On the right or left, the other side, we're going to have some text that explains what's going on with some more ASCII graphics. Okay, so that's the game plan. Of course, we're going to need some kind of project to work on. So the project is a calculator, of course, but it doesn't really matter. We're not going to look at much of the code. But it's a calculator. It's written in Node, because why not? And TypeScript, just to give you an idea of what's the source code going to be like. So let's get started with the first gem, which I call pretty logs. Now, you guys already know about git log. Now, it shows you the history of your commits. Now, this view is fine, but we can do better than that, because it turns out that git log has an option called pretty. And if you use that option, you can customize the output of git log. So for example, we can say git log pretty, and the parameter here is a bunch of placeholders for the different pieces of metadata that are part of a commit. So for example, if we just wanted to print the summary, that is the first line of a commit message, we would say %s, and then we just look at the message. Now, of course, you can do much more than this. So let's do something more interesting, where we say pretty, and then we change the color to red. Then we want to print out the hash code, but not the long one, the one that you see everywhere. We just want the abbreviated hash code, which is usually the first 6, 7 characters. So it's lowercase h. Then let's reset the color. Now let's change the color again to yellow. And now I want to print the branch references that are or the tags, whatever references are pointing to that commit. Now, if you had to guess what the placeholder for the references is, what would you say? R. But unfortunately, it's D. Because it's Git. So let's reset the color again. Then let's have a space, and then now we print the familiar summary, which is the first line in the commit message. Then let's change the color again, and let's make a cyan, and now we open a parenthesis. And now we want to print the commit date, or the author date. However, we want to print the date relative to now. So we say AR. And then we reset the color again. And this is what you get. Okay? So this is much better. It's more succinct. Can you still read the font if I do like that? Yeah, cool. So of course, all you need to do to take advantage of this is you just type this every time. You get fast after a while. No, obviously not. There is another feature which you may or may not know about in Git, which is called aliases. Now, an alias is a word that you associate to a command plus a bunch of options. You can even have a shell function associated to an alias, which takes parameters. So you can take it as far as you want. So let's write an alias. So instead of typing this every time, let's just copy that string. So we go like this, and we copy that. And then we say git config global, because aliases are part of the configuration. And then you say alias dot, and then the name of your alias. So in this case, let's call it LG. Of course, it has to be something that doesn't already exist. And then you say what command, so log, and then pretty. And then you just paste in the string that we had. So now I can say git LG. Of course, and then you can have your own customized view of the log. Pretty useful stuff. Did you guys know about this? How many here knew? Okay, maybe 20%. Okay, so let's move on to the second gem, which stays on the theme of pretty things. Because if you're going to be on the terminal all day, like I am, it might as well look good. So, pretty diffs. Now, if you do git diff, for example, let's compare the previous commit with the latest one, you get this, which is, of course, the default way of looking at diffs. However, you might not know that everything that's being piped to the terminal is passed through a program called a pager. Now, the default pager for Git is less, which is what gives you the ability to scroll up and down with the arrows or K and G. However, that's not fixed. It's a setting you can change. And there are a bunch of programs out there that do pretty things with the diff output. They improve upon it. And one of them is called Delta. Now, Delta is written in Rust. So that tells you already there that it's a cool tool. So what you can do is that you can just set the core.pager option to Delta, and now Delta is going to take care of all the diffs for you. So of course you need to install it first, which I already did, but you say git config global core.pager, and then you say Delta. And now if you do the same diff, it looks like this. And now, not only do you get the plus and minuses are gone, the headers are prettier, but also you get syntax highlighting. Now this is TypeScript, so you get syntax highlighting for your code, and it supports a bunch of different languages. So Delta is something that I would recommend you add to your configuration. Now let's move on to start changing files. Let's talk about staging. So when you work with Git, it's always a good idea to make your commits semantically consistent. What does that mean? It means that if you're making every commit should contain one logical change. So if, for example, if you're making a refactoring, that should be one commit. If you are fixing a bug, that should be a separate commit, separate from the refactoring. However, that's hard to do because once you are in the code, you're going to find opportunities to do stuff, and you're going to do it right there, right? So maybe you do the refactoring and you fix a bug. So how do you then split those into separate commits? Of course, with previous version control systems, it was pretty hard, if not impossible, to do, unless you were really disciplined. So, but in Git, you have the freedom to work as you want and still have the possibility to keep a clean history. Now, what we will use in this case is the patch option of git add. You know, git add is the command that allows you to stage your changes for the next commit. Now, what patch allows you to do, it allows you to split and just stage a portion of a file instead of the entire file. So how does that look like? Let's say that, so where I have a file called index.ts, and let's open it with the only editor that you ever need, text editor, which is? Thanks. I was afraid that someone was going to say Emacs or Nano. So Vim, of course. So now this is a simple TypeScript file, which is the entry point of this calculator program. Now there are some opportunities for improvement. So here, for example, here I spot a typo because embarrassingly enough, the embarrassing word has two R. So let's fix the typo, shall we? So we say, we add another R, so it's embarrassingly. And we made one change. Now we go down here and we say that, for example, here, I like this calculator to be really academic. So I don't want to say the numbers to add. Instead, I want to say the addends. So I kind of improved on the user feedback of the program. So now I made two changes, right? I made one change over here, which is fixing a typo. And then I made another change over here, which is kind of improving on the UX. It's kind of a feature, you could say. So how do I keep those two separate? Well, this is the scenario we have. With the git patch, I can choose to say, just stage that portion and leave this in my local directory for a later commit. Okay? So how do we do that? First, of course, we need to save this and close. And then I can say git add patch. Now, Git is going to ask me, do you want to stage this hunk? Now, the word hunk doesn't mean what you think it means. In this case, the word hunk means it's just the word for in the unified diff format, which, believe it or not, is a standard. There is the word for a portion of a patch, which is called a hunk. Now, do you want to stage this hunk? And then you get a bunch of options, which are all pretty self-explanatory. Now, but of course, you can use the question mark to say, hey, what does all those letters mean? But believe me when I say, in this case, we want to split this into smaller chunks. So we say S. So let's split. And now I get the same question. However, you see this time it's one of two hunks. And then it's the same question. Do you want to stage this hunk? And then I say yes. That's the first change. Do you want to stage this hunk? No. Now, if I do a git status, you see the file is simultaneously staged and unstaged. Now you might wonder, how do I look at what's about to be committed? Well, I say git diff staged. How do I look at what's left in my working directory? I can just say git diff. Okay? Cool stuff. Now, bonus tip. The patch also works for undoing things. So, for example, let's open it up again, and let's make a couple of more changes. For example, here, I'm gonna add this is documentation. And then down here, I'm going to say this is a comment. Just make two different changes. Now, let's say that I regret one of those. I want to remove it from my local changes. Then I can say git restore patch. And then I get the same question, however, this time is, do you want to discard this hunk from the work tree? And then it's the same kind of options, right? So I can say, yeah, split this. Do you want to discard this? And I say no. Do you want to discard this? And I say yes. And then it's our other change, of course, and I don't want to discard that. So now if I say git diff, I got rid of the comment. Cool stuff. Did you guys know about this? How many here knew about this? Also the restore. Ah, okay. Couple of you, yeah. All right. Let's move on with more staging stuff. Now, once you start splitting commits, the next question becomes, well, every commit should be consistent. It should not break the build. It should not fail the test. I should be confident enough that if I cherry pick a commit from another branch, or if I merge something, I should not worry about the build being broken. So how do I ensure, now that I'm splitting commits and I have changes in my local directory and I have changes that are staged, how do I ensure that what's staged by itself doesn't break anything? So you need to kind of isolate that in order to maybe run the tests locally. Well, it turns out that a good way to do that is to use stash. Now, stash is the command that takes away stuff from your working directory and stashes it away. However, stash has a nice option called keep index, which allows you basically to remove everything from your working directory, stash it away, but keep whatever was already staged. So in this case, I can say git stash save, but keep the index. And now if I say git diff, I don't have any changes left in my working directory. However, if I look at what's staged, that's still there. Okay? So now I can maybe run the tests and verify that what I'm about to commit by itself, with no other changes, it works, which of course it does because it's just fixing a typo, but you get the point. And now at this point I can commit, and I say fixes a typo. And now, once I'm done, of course I can get back whatever I had stashed with git stash pop. And now I have my changes back. Okay? Cool. Does anyone here use this technique? Couple of you. Okay? Cool. So let's move on to more gems. Searching. Git has some really powerful searching facilities, which allow you to search for commits that modified lines. It's more than just blame. So, for example, one of the most powerful features for searching is called pickaxe, because you go spelunking, in the history with your pickaxe. And there is one, in pickaxe, what you do is that you look for commits that either add or remove a line that matches your search pattern. So it could be something that contains wildcards, or it could also be a regular expression. But the simple one is with just wildcards. So for example, in this case, I would like to know what's the commit that originally introduced the typo that we just fixed. So right at the command line, I can use my alias, so I can say lg. And then I say S and then embarrassing with 1 R. And I get two commits back. Of course, I get the commit that we just made because we modified a line. We removed a line that contained the typo. And then we have another commit, which is the commit that originally introduced that line. So let's take a look at it briefly. And indeed, this was the commit that introduced the line. Okay? Pretty cool searching stuff through the code. Bonus tip, and this is gonna, I hope this is gonna blow your mind because it blew mine. You can search by function name. What's a function name? Well, it's whatever, it's a method in C#, it's a function in JavaScript, it's whatever has curly braces and it looks like a C-style function, basically. So, for example, I know that in this code base, I have a file called calculator, which has a function called add. Now, I want to get a list of all the commits that somehow modify that function, regardless of the line number, whatever. So, I use the L option. So I can say git log L colon, then the name of the function, which is add, and then the path to the file that contains it. So calculator.ts. Bam! I get the commit that introduced that function. Now, there are no more commits that modify it, but they will also appear right there. Did you know about this? Okay, 1, 2. Okay, cool. Do you like it? Do you think it's useful? Yeah? So remember, this works for any C-style languages. So in case of C#, that would be a method, or Java, or in JavaScript, which is the script version of Java. It works with function. So let's move on to automation. Spoiler, I have 9 gems, so we are about halfway through. And another spoiler is that the gems that we already seen it a little bit, these gems kind of build upon each other. So we're going to be using previous stuff to do more stuff. So we already been using the LG alias, for example, and we're going to be using more of the other stuff as well. So automation. Now, when you work, you more often than not find out that there is a change that you wish you would have made earlier. So, for example, I don't know, you are about to change a file that you know should have been part of a previous commit. So what do? Well, usually, if you want to keep your history clean, which you should, you make a new commit, and then you go back and do an interactive rebase and squash the commit into a previous one, so that it looks like the change was already made from the beginning, right? Now, this kind of workflow is so popular that there are features in Git to automate it, to speed it up. One such feature is called auto squash. And you might wonder, why is this not on by default? Well, it's not. So you need to enable it first. So you say git config global rebase.auto_squash true. Now what this does is it allows you to speed up this workflow that I talked about of amending previous commits. So now what do we have? We have a change, this addend. Let's say that we want to make this change part of the commit that originally introduced this line. Okay? So we want to amend that earlier commit. But we don't know which one that is. And also we have 2 changes. We don't want to commit this change. We just want to commit that one and squash it into a previous commit. So let's use all the stuff that we've been looking at today, right, so far. So first we need to do a patch commit, right? So we say, do you want to stage this? No. Do you want to stage this? Yes. Perfect. So now we have just staged that change. Now let's find the commit that originally introduced that line. Of course, we use the pickaxe together with our LG alias So we say S, and then the number, it was called numbers to add. What was the commit that introduced that? Well, it's this one. Perfect, let's grab the commit hash. Now what we do is that instead of simply committing our change, we say commit and then dash dash fix up, and then we give it the hash of the commit that we want this to be squashed into later. Are you with me? Yeah? And what happens next is that, of course, you get a regular commit. However, the commit message contains the word fix up with an exclamation mark. So you can think in your head like, fix up! And then you get it. You get basically the same commit message of the previous commit. Now, once you have a bunch of those, of course you can, and now at this point you can keep going with your workflow. You can do more changes. And if you realize that you have a change that should have been made earlier, you do the same thing. You do a fix-up commit, and then you keep going. So you end up with a bunch of proper real commits and a bunch of fix-up commits all mixed together. Now, once you are done, in the end, you do one interactive rebase. So you say git rebase interactive, probably just say -i. And in my case, I'm going to do it for the whole history. So I'm going to say start from the root, but you're probably going to say from the branching point. And oh, has this ever happened to you? You want to do a rebase, but you have modified files in a working directory. So you need to stash them. Well, this is a so common problem that there is a feature for it called auto stash with capital S. It's important, otherwise it doesn't work. So with auto stash, of course, it's also something you need to enable. So you say git config global rebase dot auto stash, remember the capital S, true. And now I think you can guess what it does, right? So once you do an interactive rebase, you didn't see it, we're going to see it later, but it allowed us to do the rebase. So you see what happens here. The fix-up commit has been moved into the right spot just below the commit you want to squash it into, and the action has been changed into fix-up. So as I told you before, you can have a whole bunch of these that you make, and they are going to be moved into the right spot, and the action already changed. So all you have to do here, you just have to quit and save, and the rebase is done. And you see what happened here. Created the auto stash. It allowed us to do the rebase, and then it reapplied the auto stash. So the changes in my working directory are back. And of course, I have nothing in the stash. So that's really useful. And also, if we look at the history, we see that our fix-up commit is gone. It was the latest one. Now it's been incorporated into this. So let's take a look at how this looks like. And you see that it says the addends. So it looks like I wrote that from the beginning. Okay? Lots of automation stuff. Let's keep going with something visual, the dot notation. Does anyone here know about the dot notation? What about the dot notation? Okay, one. What about the dot notation? No one. It is a real thing. So it's 2 dots or 3 dots. We're going to look at the 2 dots today. So what does it do? Well, usually you are going to always, let me just get rid of that change. You are always going to be asking the question, what commits are in this branch that are not in that branch? Usually you are in a topic branch or in a pull request branch. You want to know what commits are here that are not in the main branch. A quick way to do that is to use git log together with the dot notation. So for example, let's say that you have this situation. You have a topic branch and a main branch. Now, what you want to know is what commits are in the topic branch that are not in the main branch. Okay? So, in order to do that, you say git log main.topic. This means show me the commits that are not here, but that are here. So the first reference is always the negative. So not here, but there. Okay? So in this case, let's switch to a topic branch. So I have a feature add test script. That's a topic branch. What commits are here that are not in main? So I can say git lg main.dot feature add test script. And I get this list. Now, of course, the opposite is very easy. If I want to ask the question, what commits are in main that are not in topic, all right, I just reverse the two references. So I can say not in topic but in main. So in this case, I can say git lg not here, but that are in main, and I get that. Okay? Of course, instead of saying the name of the branch, you can say head, because head is always the branch you are currently having your working tree. Now combine this with the aliases feature, and we can start doing some interesting things. For example, let's say that you have an alias called new that shows you what commits are new in my branch that are not in the main branch. So how do you do that? You can say git config global, then you say alias.new, and then you can reference aliases from other aliases. You could not do that in the beginning. So that in version, I think they added in 1.8, something like that. But before that, you could not do that. You couldn't reference aliases. So you can say lg, and then you can say what's not in main or master or whatever or default or whatever you call your long-running main branch. Dot head, which is the branch you're currently standing on. Now, what about the opposite? I can have an alias called missing. So I can say git global alias.missing, and then I just reverse the two things. Not here, but in main. Now, when I'm in a topic branch, I can say git new. This is the new stuff. What am I missing? This is the stuff I'm missing. I use this all the time. It's like automatic. Git new, git missing. Cool aliases to have in your git config. Okay. Let's go into the advanced stuff. Rebase onto. Have you heard about Rebase onto? Couple of you, okay. Do you use it every day? One? That's impressive. Okay. What does Rebase? Rebase, you already know what it does. Changes. It changes the base of your branch into another base. What does Rebase onto do? Well, Rebase onto allows you to take a chunk of a branch, a portion of a branch. So it doesn't start from the branching point. You can say whatever range of commits within a branch, and you transfer it to another base. You can say branch surgery. So Rebase onto. How is this useful? Well, let's say that you have a situation like this, which is the one we have. And we have this commit over here that we have now amended. We made a fix up, if you remember. So we changed it. It means that whatever topic branch was based on top of that now contains the old version of that commit, right? While the main branch now has the new version, which is exactly what we have if you look. Let me see here. If I can do git new, git missing. Do you guys spot something interesting in these two? we give you a hint. So what's new in our branch is actually the old commit, and what's in main, it's the new amended commit, right? So now how can we get rid of this situation? What we want to do basically is we want to take these two commits over here, and we want to move them so that they become based off of main, thus removing this commit altogether. So this is what we want to do. Take those two, move them on top of main, and get rid of that old B. So you can do that by using rebase onto. So how does the syntax look like? Well, it's very simple. You say git rebase onto, and then you say new base, and then you say what was the old base, and you give it as a second parameter. So in our case, it's going to look like this. Rebase onto main, the new base. What was the old base? It was the old B, which is going to be excluded. So in our topic branch, we say rebase. Well, first we need to find the old B, which is this one. So let's grab the commit hash. You can also say origin main in this case, because there is a branch reference. So rebase onto main. What was the old base? It was B. And now in just one operation, I have no longer B here. I just have the new commits. So what I did, once again, I took those two commits and I moved them up so that they're based off of main. And this way I got rid of the old base, which is B. So that's rebase onto. And it's a very quick way to also delete commits in a branch. Like let's say that you have 10 commits and there are 2 in the middle that you want to remove. You just say rebase onto what was the first of the old commits you want to remove, and what is the new base you want to use, and you basically remove commits that are in the middle of a branch. I know, it takes some getting used to. Now you know about rebase onto, so you can explore it further. Because there is another variant of rebase onto with 3 arguments, where you take just a chunk in the middle of a branch and then move it somewhere else. So I encourage you to look it up and start adding it into your toolbox, because it's very useful. Of course, in the end, we end up with a linear history like this, which is what we have. So we are actually really ahead of schedule. So let's talk about gem number 8, which is the reflog. How many of you here know about the reflog? Okay, a couple of you. So what is the reflog? Well, Git doesn't only keep track of your files, it also keeps track of its own files. And Git's own files are the references, the branches, or the tags. Now, every time a branch changes, so you make a new commit, or you rebase, or you reset, Git remembers what commit was that branch pointing to before this operation, okay? And that list of changes is called a reflog. Now, every branch has its own reflog, which you can get to by saying git reflog and then the branch name. So, for example, feature add test script, and you get the reflog for that particular branch. Now, you might actually, let's look at main's reflog, which is a little bit easier. So in the main, this is its reflog. What you see is that every entry has the name of the branch, then the @ and then a number, which increases. Now, this is the higher the number, the older the entry is. So the latest one is always 0. That's where we are at now. And the oldest ones are the higher numbers. And you see what kind of changes is it. You see the fix-up commit we made, the other commit, resetting, rebasing. So these are the commits that that branch was pointing to before those operations. So how can we use, and another thing to know is that head, which is the reference that points to the branch you are currently have checked out, head also has its own reflog, which you get to by saying just git reflog. And this basically contains the same thing, however, it's head instead of the branch name. And another thing that reflog for head contains is every time you move a branch. So every time you do a checkout or a switch, the reflog for head remembers what branch did you have checked out before, which is something that you can use, and I'm going to show you. But first, let's look at how can you use the reflog. Well, let's say that you have a situation like this, which is the usual situation. Now, we did a rebase, so now the history looks like this. But what if we change our mind? Now, the rebase is complete, is finished, but now we want to go back to where things were before the rebase. Well, how do you do that? I mean, the old commit is no longer visible in the history if you do git log. However, it's still there somewhere. And what's pointing to the old, in our case, D, before the rebase, what's pointing to it is, of course, the reflog for that branch. And if that was the last operation we did, it's going to be number 1, because 0 is where we are right now, and the previous reference, the previous commit that the branch was pointing to is number 1. So now that we have a way to get to that commit, it becomes pretty trivial to undo things. Because now we made a rebase, I can just say reset, which is how you change the branch reference to something else. In this case, you say hard because you really mean it. No, you say hard because you also want to change your working directory and the head reference so that everything is synchronized. What do you reset it to? Well, you reset it to feature at test script at 1. And now if I say git new, I get the old B back, the one that we had got rid of before. So reflog is basically Git's universal undo machine. Now you might wonder, how long are these things being kept around in the reflog? Well, usually it's 30 days. So entries older than 30 days are going to be dropped out of the reflog. No, actually, scratch that. I think it's 90 days. Entries older than 90 days are going to be, no, oldest one that just get removed from the reflog. And of course, it's a setting that you can change. Now, keep in mind that Git has its own garbage collection. So commits that are not being referenced by anything, like in this case, once we did the rebase, there was nothing pointing to the old B apart from the reflog. So once it also drops out of the reflog, then there is really nothing pointing to the old commit, and the garbage collection is going to remove it, together with the whole files associated to it, right? The blobs and stuff. So that's good to know. The reflog stays there for a few months. So you can always go back. And bonus tip, since we have a bit of extra time, what if you don't know what entry something is in the reflog? Now we can combine all that we already know. For example, remember the pickaxe? Well, you can say git lg s and then some word that was in the files. So for example, I don't know, the addends. And then if you add walk reflogs, this tells git log to not only look at the history with that pickaxe, but also look at the reflog. And now I don't get anything because there is nothing there. But always add reflog. Another thing you can do is that what if I remember the commit message? I don't remember the change, but I remember some word in the commit message. Then you can say git lg grep And then you can say what was in the commit message, a word. For example, you can say, I don't know, add. And then you say walk reflogs. And now you get all the commits that contain the word add, however you get them from the reflog. All right. And that's what we did right now, right? We resetted the topic branch to the entry in the reflog, and now we're back to that situation again. We're doing really good on time. So let's look at our last but not least gem, which is my personal favorite. It's called Rerere. Do you know about Rerere? Does anyone here know about Rerere? No? Oh, no. Okay. So then it means that someone here knew about everything. Okay, look me up afterwards. Rerere, what is that? What on earth is Rerere? Well, it stands for Reuse Recorded Resolution. Now, we all know merge conflicts are a fact of life. And they happen more often than not. And have you ever been in a situation where you have to resolve the same conflict multiple times? Yeah, it happens. Now, there are many reasons why you might have to do that, but one particular reason that comes to mind is there is a very common workflow that is being used in the Linux kernel development, which is called the test merge workflow. So let's say that you have a topic branch, which is kind of long running, so you keep it around for a longish time. However, your main branch is also going to move ahead. What you want to do is that you want to make sure that what you are doing doesn't conflict with whatever is happening in the main branch. So what do? You regularly do merges from the main branch into your own topic branch. However, you don't keep all of those merge commits around because they will clutter the history. What you do is that you do a merge and then you don't commit it. So you basically do a merge, but you do not continue until the merge commit actually is created. You just interrupt it before. But what gives you the opportunity to do is to see if there are any conflicts, right? You just do a merge. Are there any conflicts? Yes. If you have Rerere enabled, you can resolve those conflicts. The resolution is going to be recorded, and then you can get rid of the merge commit, but the resolution is still recorded for later. And if you keep doing this regularly, you're going to be solving the conflicts, at regular intervals. Then at the end, once you are ready to merge, you're going to have, of course, the same conflict because you deleted the merge commits. However, all the resolutions are going to be reapplied. Okay? So the test merge workflow is pretty useful to do if you have a long-running topic branch and a fast-moving main branch. Okay, so how do you do it? Of course, you need to enable it first. So config global rerere enabled true. Yeah, it's always funny every time. And remember that nothing is recorded until you enable it. So previous merge conflicts that you resolved, those are not going to be recorded. However, there is a Python script that tries to recreate, to look at the merge commits and trying to record the resolution. But it's hit and miss. So from the point when you enable it, then it starts recording. And how does it look like? Well, we are in our feature branch. Let's say that we want to merge it into main, okay? So we switch to main, and then we say merge feature add test script. Now we have a conflict. But notice in the output, it says recorded pre-image for the file that has the conflict. Now this is Rerere that's printing that out. Now, of course, we can take a look at the diff, and you see how delta formats the merge conflict in a pretty way, making it really easy to see what's what. Of course, the line that's conflicting is this, the addends. In our topic branch, it says still the old one. This is B conflicting, this is the old B conflicting with the new B, right? So the numbers to add and the addends, which one do we want? Of course, we want the new one, the one that's in head, which is the target of the merge. So there is a quick way to resolve this conflict. We just say restore ours. We want our version of the file, not theirs, which is the topic branch. And then we say index. Perfect. Now we have resolved the conflict. You need to tell Rerere that this is the resolution. And how do you do that? You do it by staging the file with the resolution. And then you can just say merge continue. Of course, you get the message, and then you save. And notice here, recorded resolution for that file. OK, now let's say that we change our mind. We want to remove the merge commit, which is what you will do in the test merge flow. And you say git reset hard, go back to the parent of our latest commit. That little character there, the caret sign, means the parent of the previous commit of head. So let's reset. Now we have no longer a merge commit. We are back to this situation over here. And let's say that now we want to, instead, we want to rebase so that we get a linear history instead. Now remember, a rebase is still a merge. It's just that every commit is being applied one at a time instead of merging two commits. So if we switch back to our feature branch and we do a rebase to main, we're going to get the same conflict again. However, this time we get, hey, it was resolved using a previous resolution. Now remember, Git is very conservative. It doesn't just reapply a previous resolution and go ahead and continue and no, complete, done. Because, of course, things change, and a previous resolution might be obsolete now. So it always stops and gives you the chance to check, does the resolution still apply? So you can take a look at the file, src index. You see that it reapplied the addends like we have done previously. So this looks good. Let's confirm that it does by adding it to the index, and then we say rebase continue. And now we're done. Okay? And this, of course, works with other ones. I can show you one thing more. That is, then what do you do if the resolution is obsolete? How do you remove a previously recorded resolution? Well, once again, now we're going to use what we already learned. Now we have rebased. How do we get back to before the rebase? What do we use? The reflog, right? So we can just reset hard feature at a script at 1, because this is the last thing we just did. And now we're back to before the rebase. Now let's do the rebase again. Of course, we run into the same conflict. However, this time the resolution doesn't apply anymore. So what do? We say git rerere forget src index. And it says, I forgot the previous resolution, and now you need to, of course, resolve it again and do the same thing again, right? Which is going to record the new resolution afterwards. Now you might wonder, where are those recorded resolutions? Well, of course, they are in the Git directory. There is a directory called rr cache. Why not rrr cache? I don't know. You tell me. But that is where they are. And there is a directory, of course, into that. There is a directory for every, and now we forgot about it, so there are no files. So let's continue and look at how it looks like once you resolve the resolution. Yeah, the file is already being changed. So now in theory, we would apply a different resolution. But in this case, we're going to keep it the same. And then you say rebase continue. And it was rebased. And now hopefully it has recorded. No, because I actually didn't add. Never mind. What happens is that in that directory there are going to be 3 files. One with the one side of the conflict, one with the other side of the conflict, and one with the final resolution. And that's how Git recognizes that the same conflict appears again, if each side is the same. And it reapplies the 3rd file, which was the resolution. All right, let's sum this up. We have looked at 9 gems. First one was pretty logs. Use the pretty option of git log to customize the way you look at history. Then we looked at pretty diffs. Highly encourage you to add delta as your pager. Makes life really easier when you look at diffs. Staging with the partial staging with the git add patch, and restore patch to individually remove changes from your working directory. Then we have the searching facilities with pickaxe. Look at commits that either add or remove a line that matches some text or some regular expression. Automation. Remember about auto squash and auto stash to speed up the workflow where you go back and amend previous commits. The dot notation allows you to compare branches, what's in this branch that's not in another branch, and then you can associate those to aliases to create the new and missing aliases, to quickly determine what's new and what's missing in your topic branch. Then we looked at Rebase onto, which is the advanced version of Rebase, where you take portions of a branch and move them into a new base, which is a good way to get rid of commits that you no longer want in a branch. Then we looked at Git's universal undo machine, which is the reflog. Keeps track of every branch, what commits they were pointing to. And you can use that together with reset to go back to previous states. And you can use the walk reflogs option to do searches like we did with pickaxe, but you can search in the reflog as well. Walk reflogs. And finally, Rerere, which is reuse recorder resolution. Git remembers how you solve conflicts and automatically reapplies the same solution once it sees that the conflict is the same on both sides. Now, there are many more features like that in Git. You can imagine. Of course, I cannot show you everything. So I have a course out on Pluralsight called Advanced Git Tips and Tricks that covers some of this stuff and stuff that I wouldn't have time to show you today. So if you have Pluralsight, I highly encourage you to check that out. And with that, I'd like to thank you for your attention.